Hello everyone and welcome to another video with Special Maths Academy. In this video, we'll be looking at the 12th problem from the 2023 Special Maths Contest, the first round, and it says, given positive integers a1 less than or equals to a2 less than or equals to a3 less than or equals to a4, let f of a1, a2, a3, a4 denote the number of ways of filling a 4 by 4 grid with a1 plus a2 plus a3 plus a4 dots in such a way that each grid contains at most one dot and both row K and column K contain exactly AK dots. Suppose that F1, 2, 3, 2, 3 equals to 24, F1, 2, 3, 3 equals to 13, F1, 2, 3, 4 equals to 1. Find F1, 1, 2, 3. Okay. So this is an interesting question. Okay, so let's see what we can do about this question. So the first thing we can observe is that, okay, let's see what a pattern looks like. So I already have something copied. So yeah, let's work with this grid. And let's see what the pattern looks like. So for example, as you can see from the thumbnail, if we have F2, 3, 3, 3. Okay, so can look something like this. So the first column and first row can put 2. Okay, now the second column and second row we already have 1, 1. We need 3, so you can put 2 more here, here. Now the third column and third row we only have 1, 1 on each, but we need 3. So okay. The last column and last row, we have 2 to each, and yeah. So you can analyze this and see that this gives us the an example of F2333. Okay. So now something that's important here, how we're going to count this, we're going to focus on counting the complement. Okay. So basically, if we look at the the cells that don't have any dots at all, that maps to, okay, so let's say we have F A1, A2, A3, A4. Okay. So from the set of grids that belong to this, there's exactly, okay, one set that we can map to, exactly one grid that we can map to 4 minus A1, 4 minus A2, 4 minus A3, 4 minus A4. Okay. So there's only one that can map. So for instance, if we want to create an example of F, so 4 minus 2 is 2, 4 minus 3 is 1, 4 minus 3 is 1, 4 minus 3 is 1. Want to create this example, we can look at this. So let me paste my grid again. Okay. So we can look at this, just fill in the ones that are empty. Okay. 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 So this is an example of F2111. Okay. Then something else we can see is if we, you know, perform some reflection. So if we like let me create an axis. So if we perform some reflection across this diagonal, okay, then we can say that F A, so this FA1. So each of the countings in FA1, A2, A3, A4. Okay. So we can form a bijection between each of the grids that appear in FA1, A2, A3, A4 with the grids that appear in A4, A3. So just reading it from the back. A2, A1. Okay. Okay. So armed with these properties, let's see what we can do. So remember, we want to find F1, 1, 2, 3. Okay, of course, one can try to, solve this manually, but the reason we have these examples, so the goal of the problem is for you to like look at this examples and see if you can figure out how to get that without solving directly, okay? By just performing some operations. Okay. So we can perform the first operation. Okay. So swap the empty cells for with the filled cells. So that's 4 minus 1. So this is equal to, so 4 minus 1, 3, 4 minus 1, 3, 4 minus 2, 2, 4 minus 3, 1. Okay. And then we can perform the rotation across this diagonal. Okay. So this is equals to 1, 2, 3, 3. Okay. So 1, 2, 3, 3, as you can see, is this option here. So that's option C. Okay. And I hope you learned something new from this video. Different ways you can perform different operations to make your counting task easier. And to all the prospective contestants for the next edition of the Special Maths Contest, I want to wish you a good luck and I hope you blaze the exam. See you in the next video. Bye, everyone. Don't forget to like, share, comment, and subscribe. And yeah, we're grateful for the view. Goodbye, everyone.